Hi all, in this video we are going to see how to evaluate the performance of the classification model in terms of the confusion matrix. And the confusion matrix is a table where the performance of the classifier are summarized to represent in a table format. The other name for the confusion matrix is the contingency table. And here the rows represent the actual and the column represent the predicted. For example, we have a binary classifier model and the binary classifier having two classes. So we have the label 1 and label 2 or the class 1 or class 2. So here the row wise represents actually how many are with the label 1 and label 2. And the predicted represents how the model giving the output with the prediction of label 1 and label 2. And now we are seeing this problem on example, and here we have a binary classification model which is used to classify the animal with the two category of cat and the dog. So actually we are having the total input of 7 cats and the 13 dogs. Okay, so the actual represents totally how much we are having. So we are having totally 7 cats and the 13 dogs. So now these inputs are given to the machine learning model, whatever we have generated for the classification purpose. Out of that, the machine is predicting the cats are 8 and the dogs are totally 12. So in this case together totally we are having 7 cats, but my machine has predicted out of the 7, 6 only corrected. So automatically 1 is going to a dog. So this is false negative. And then out of 13 dogs, the machine has correctly classified 11 as dog. So remaining 2 becomes as cat. So we can see here positively it is cat, and the machine also predicted this is a cat. This is called as true positive. And here the other class we are considering as negative. So here actually the class is also dog. The predicted class also dog. This is called as true negative. And now this is actually cat, but it is unfortunately predicted as dog, or falsely it is predicted as dog instead of cat. That is called as false negative, which will be otherwise called as type 2 error. And in this case this is actually a dog, but it is unfortunately the machine predicted this is a cat. So it is called as false positive. So when you have this negative and positive, you just consider the input is positive and the predicted also positive. So it is truly positive. The input is negative, the predicted also negative. So it is truly negative. Here the input is positive, but it is falsely predicted as negative. That's why it is called as false negative. Here the input is negative, but falsely your system predicted it is a positive. That's why it is called as false positive. Always remember, the row wise have a actual value, column wise have a predicted value, and the diagonal represent the correctly classified element, truly positive, truly negative. And here this is false negative and this is false positive. So this is the confusion matrix we have to represent with true positive, true negative, false positive and false negative. Here is the problem where the machine has to classify the emails to be spam or not spam. So totally we have 100 examples. In that actually the label represents 65 are spam mail and 35 are non-spam mail. So now the machine has predicted this in terms of the total spam is 50 and the total non-spam is 50 again. Okay. So now we see here out of 65, 45 only classified correctly as spam. and out of 30, 30 only, out of 35, 30 only classified correctly at non-spam. So remaining belongs to either false positive and the false negative. And we have some performance metrics which will get the evaluation of your model to know the performance of your machine learning model. So they are, first one is the accuracy. Accuracy represents the number of correctly classified instance over the total instance. Okay, so the formula is correctly classified is true positive and true negative. In that with the total. So correctly classified instance divided by the total instance. The next is called as sensitivity or the true positive. It measures out of all the positive cases. So this is our positive cases. Out of all positive cases, how many positive will be classified correctly or how many positives will be predicted correctly. So that is called as recall, or you can just remember it is a row wise calculation. Totally how much is positive out of that correctly predicted. And next one is called as precision. So the precision represents correctly classified thing. How many positive is correctly predicted? That is how many is predicted by the computer as a positive, that is your machine learning model computed as positive. Out of that, with how many is correct. Okay, so here 50 is classified as predicted by your model. Out of that, the correctly classified is only 45. Okay, the correctness achieved in the positive prediction, how your machine predicted, in that how much correctness is there. That will be called as precision, or you can just remember the column wise you have to calculate the positive predictness. And next is the true negative rate or the specificity. It represents how much is predicted correctly out of the total negative class. Negative means here we have the non-spam. So totally we have 35. Out of that, how many is correctly classified as negative? So this is also we are considering row wise for the negative samples. Okay. So now the last measure is called as F1 score or the F measure, which is the balance between your precision and the recall. The harmonic mean provides generally a single score that balance between the precision and the recall together in a single value. This value will be always between 0 to 1. If you have the F1 score value near to 1, your classification or your model's performance is good. Okay. So generally the accuracy will be misleading on the imbalanced data. For example, you have totally 100, in that 90 having a positive class and 10 may have the negative class. Okay. So sometimes the machine will provide good accuracy for it. For the imbalanced data. So that problem you can overcome by using the F1 score. So F1 score is nothing but 2 into recall into precision divided by recall plus precision. So now we will apply all these formulas, that is accuracy, recall, precision, sensitivity and the F measure. So now we have everything together here. First we go with the accuracy. Accuracy is correctly classified divided by the total instance. So totally positive how many correctly classified, negative how many classified. The total instance means everything together. 45 plus 30 plus 20 plus 5. That will be 75 divided by 100. So we have 0.75, or you can represent it as your system will providing an accuracy of 75%. And recall, as I told, just remember it is a row wise positive. So actually how many is positive? Out of that, how many is predicted correctly as positive? So 45 is predicted positive. Out of the total positive is 65. So that is 45 plus 20. So we are getting the answer with 0.69, or you can give it as a 69%. Then go with the precision. Precision represents out of the machine predicted positive, how many is correctly positive. So which represent 45 divided by 45 plus 5. That value is 0.9 that is 90%. So your machine is able to predict 90% positive samples correctly. Then negative, for that we have the specificity. So this thing you can just make it as it is a column wise calculation and this is a row wise calculation. And specificity, which will be concentrating on the negative sample, that is the non-spam class. Out of the actual non-spam, how many is correctly classified? So 30 divided by 30 plus 5, which will be leading to 0.85, that is 85 percentile. So this is negative with row wise. And followed by we have the F measure, which is a balance between recall and precision. So 2 into the recall value is 0.69, the precision value is 0.9, divide by recall is 0.69 plus 0.9. So we are getting 0.78. So which is above 0.5. So almost your model providing the good performance with the 78 with the F measure score. So now we have the next problem. Here we have three classes. This is class 1. We can just make it as red, and this is green, and this is blue. We have red balls, green balls, blue balls. Okay, so we want to predict it correctly. So now we have three classes. So how will you calculate the accuracy? Accuracy always represent the diagonal value which will be classified correctly or predicted correctly. So 15 plus 15 plus 45 divide by 100. So that will be 75 divided by 100. So 75% accurately your data are classified. Now recall. So recall is how many is positively correctly classified with the out of the samples. So total 20, in that how many is correctly classified is 15. So now we have three things, red, green and blue. So we have to calculate the recall separately for all the three classes. So recall for red. So that will be 15 divided by 20. And recall for green. So that will be 15 divided by 30. Then recall for blue. So that will be 45 divided by 50. So what is the recall? That is the average which represent recall for red plus recall for green plus recall for blue divide by 3, which will be giving the average recall, because in a real time we will not have only the binary classifier. We are having the multi-class classification. So that time you can get the recall class wise and also you can get the overall or the average recall of your machine learning model. Similarly, you can do for the precision. So precision you have to consider column wise. So precision of red color 15 divided by 24. Then precision of green color, that is 15 divided by 20. Then precision of blue color, and that will be 45 divided by 56. Then you can take the precision of the average, which will be giving the precision of your model in an average. So here you can see here accuracy is there. Then you can calculate the recall and the precision class wise, and you can take an average of all these. That will be obtaining a single precision and the recall for the whole classifier. I hope you got a clear idea what is meant by confusion matrix, what are the informations available in the confusion matrix, and what are the performance metrics you can evaluate through the confusion matrix for the classification model. That is accuracy, sensitivity or recall, precision, specificity and the F1 score. Thank you.